Good evening, everyone, and thanks for inviting me to chair to moderate the panel tonight. I've been given 7 minutes to introduce the topic, but I've not been told how to advance the slides. There we go. So as it was said, I'm a professor of robotics. I've been active in this domain for 20 years, and tonight we're going to talk about robotic dexterity. So if we move to the next slide, I think that most people, when we talk about robots manipulating things, they think about something like the classic automotive industry. This is the infamous Tesla robot dance. This is the line of robots that assemble the Model S, I think. Sure, this is probably one of the most active areas in robotic manipulation these days, but this is a very constrained environment, very well preconditioned, but this is probably not what we're going to talk most about tonight. What we're going to talk about tonight is much harder, and it's exemplified by what is called the Moravec's paradox. This is a book that appeared 30 years ago. So the Moravec's paradox that you can read there, actually I can't read it because I don't see it very well, but anyhow it says that it's much harder or much easier to make a computer. A computer exhibit human-like performance in tasks like checkers, or maybe in these days would be AlphaGo, than to replicate the ability of a 1-year-old when it comes to mobility. And for the kind of things we're going to talk about tonight, the mobility we're interested in is actually dexterity. And 30 years after Moravec's paradox was announced, most people would argue that actually it's still true today. And what is dexterity? Well, since we are in Stanford, I thought it would be interesting to actually quote one of the papers by Professor Okamura and collaborators, which are here at Stanford. Well, they say that dexterity is the ability to move things with different fingers and devices. And what is interesting at the end is that it cannot be accomplished without a dedicated gripper. Okay, so you need something which is specifically designed for this specific challenge. Still, I guess that if this is the definition of dexterity, it calls for special hardware solutions. But then I guess that each of us have seen this movie or this piece of news that came out this week, the robot that has put together an IKEA chair. Okay, this was in the news this last week. The IKEA test actually has been around a while. I heard about it 10 years ago. Maybe it's the equivalent of the Turing test for artificial intelligence. The IKEA test is the equivalent for dexterous manipulation. It's not the first time that a robot puts together a piece of IKEA furniture. Actually, this was done already in the past for an easier piece of furniture. But what is very interesting about this system is that if you notice the kind of robot that is used and the kind of actuator, this is actually a parallel jaw gripper, which is the simplest type of gripper you can imagine possibly. And so the question now is that perhaps you don't need novel hardware. This is one of the controversies we're going to discuss about tonight. Maybe everything can be done just with AI and machine learning, as everything else in life these days, right? So the question is, can AI automate automation? Can we actually extract unsuspecting capabilities from existing hardware by just leveraging what AI and all these algorithmic advances are giving us these days? And this is not a point solution. Actually, this most dexterous robot system that came out of Berkeley, Ken Goldberg's group, this is, I think, back in March, more or less achieves the same kind of unsurprising performance. And if you look there, the right hand is a parallel jaw gripper, the left hand is a suction cup, so something extremely simple and nothing new at all. But thanks to advances in AI, and in particular cloud robotics and deep learning, so I think we're good. We mentioned deep learning tonight, so our job is done. They managed to do something that was actually surprising. So the question that we can ask then is, okay, we can imagine two alternative approaches. One is perhaps horizontal, which is what I call the general purpose AI, which means, okay, you don't need new hardware. Actually, if you just leverage novel approaches in AI, like we have just seen, perhaps you can have a computational machinery that can be applied broadly to a lot of different existing pieces of hardware. Or on the other hand, we can think perhaps about the vertical approach, which is exemplified by two of the companies that are here tonight, where actually no, you come out with novel hardware designs, and we're going to hear about that later, and then on top of that you implement novel software. And so which way is the way to go if you want to really achieve robots that can overcome Moravec's paradox and exhibit human-level grasping capabilities? What are the opportunities? Well, seems like my slide was not correctly saved from earlier on, but service robots actually is any robot which is not in the industrial environment. And once we will have robots that are really dexterous, maybe we can send them out of factories and do different things. And this is a chart from the International Federation of Robotics from 2016. It's the latest one that they publish, and you can get them on for free on their website. And the interesting thing is that they anticipate that actually service robotics is one of the areas where there is anticipated growth at a sustained rate in the current future. So the moment dexterity comes, actually robots will be able to get into a variety of other places. Since it is a VLab event, we have to talk about who could be disrupted. And well, if one thinks about who could be disrupted, actually perhaps are traditional automation companies. So if you go to the web and you just search top 10 industrial automation companies, you more or less get that picture. And interestingly, Siemens is there. So we have one tonight that can tell us what they're doing about this changing horizon. And finally, in terms of controversy, of course, if we talk about robotics, one of the obvious controversies is, okay, what is the impact on the job market and on society and what not? We should all be cognizant about that. And so many of you probably have seen this report that came out from McKinsey last year, December, something like that. You can get it on the web. And it says that more or less 1/3 of the jobs in the US are poised to be impacted by automation, and impacted means not positively impacted. 2 weeks ago, something came out from, and you find it on the Financial Times, the Asian Development Bank analyzes the same data and says that actually robotics will create new jobs. So obviously we don't have the answer about this. This is one of the controversies we have to be cognizant about, and apparently the best experts in the world start from the same data and come to exactly opposite conclusions. I guess that's all I have to say for tonight to introduce the topic, and I guess now it's time for the presenting startup before we start with the questions and answers. Thank you.
Now, the organizers told me to sort of weave the founder story along with the company story. So I'll attempt to do that, but I wanted to tell the students, Isha and team, that you can look forward to more adventures with bankruptcy, financial issues. So welcome to robotics.
Very good.
So I'm the co-founder and chief technology and products officer of a startup called Grabit. We are sort of a mid-stage startup in Sunnyvale, and we are focusing on difficult to automate material handling tasks, and I'll talk about what those are. Next slide, please. So what's sort of the driving force for all of this drive towards automation? There's two areas, at least from our perspective. One is the need to manufacture close to shore so that you can service people close to shore. And that sort of has implications with delivery in the logistics space. It also has implications in the manufacturing space in terms of speed to market, small batch, rapid prototyping of the stuff that you need to put out so that you don't have to put it on sale if you guess wrong, and then where the product is manufactured because of the labor costs are going up. So all of this together is causing a drive towards automation that I'm sure all of you are familiar with. Next slide, please. But if you look at sort of where automation is mature, relatively speaking, and where it's not, there are things like automotive and semiconductor, which are all highly automated. Stefano showed slides about that. But there are other areas which are massive industries, trillions of dollars, apparel, footwear, even most of logistics, believe it or not, agriculture, which are massively labor intensive still and are running into a lot of challenges in terms of business model. To the old way of doing things is no longer sustainable. And if you look at what the difference between these two, it's in the materials that need to be handled. When you're handling fabric, when you're handling items, when you're handling boxes, there's inherent variation in what you're handling. When you're handling automotive parts, when you're handling semiconductor, everything is standardized. You can build automation around a predictable shape and size. And that sort of brings us to sort of the core technology that, next slide, please. So if you look at sort of what's driven industry adoption in robotics, broadly speaking, it has to do with this idea of dexterity. Materials that are standardized and don't require dexterous operations, those kinds of tasks have high productivity and high automation. Tasks that require high dexterity, and it doesn't require necessarily human hands, I'll show about examples of things that don't, are where we are lagging. So dexterity is basically at the forefront of limiting automation, generally speaking. Next slide, please. So if you can play the video there. So what does Grabit bring to the picture? We are a spin out of SRI International, which I understand is one of your sponsors here. And I was at SRI, and the technology that my team developed there was called electroadhesion. Basically, it's electrostatics on steroids, and we use electrostatic forces and induce electrostatic forces on foreign objects, and are therefore able to grasp it in a very general purpose way. In the interest of time, I'll move on. Next slide, please. So this is kind of where I want to talk about my story a little bit, and Grabit's story, which are unfortunately intertwined. So I showed it as sort of in the presentation as a problem that then can be solved with a general purpose technology. But that's not how the actual story was, right? We had a technology which we developed and used in all kinds of applications. And then we went out finding the most valuable problem that would apply to the technology. And that's how we ended up with these difficult to handle tasks that we can do and nobody else can, as sort of our unique value proposition. And I wish I'd sat in a conference room and thought about it, but that's not how it worked. We released products into the field. We sort of had a lot of customer learnings. We played in traffic. We really iterated on where the customer demand was that required our technology. And that's how we sort of ended up with where to focus. And the areas that we're focusing on today are in two areas. One is in warehouse logistics, and one is in manufacturing of soft goods, apparel, footwear, anything that's soft and pliable that you cannot automate without this technology from our customer point of view. So the journey was sort of this problem looking for a technology, sort of the most valuable problem to solve. But then there was a second journey of how do you solve that problem. We started off basically collaborating with the channel. We sold grippers to integrators, and we realized that was not solving our customer problems, either because of economic value or because of how the problem was not being solved holistically. So a few years ago, we decided to take a different tack and build what we call appliances. And appliances are basically a system solution that has our technology at the heart of the product, but is an end-to-end solution that involves user experience, that involves software, that involves learning, that involves vision, that involves robotics, and our technology at the heart of it. And the sort of doing this in this way allowed us to really solve our customers' problems. So having sort of started with the technology and then finding the most valuable problem, then we switched and said, okay, these are the one or two valuable problems that we want to focus on. What else besides our technology is necessary to solve that problem in a holistic way? So this is the journey that we went to sort of through with customers in the loop, and is, I think, a part of sort of doing this in a capital efficient and a lean way is one of the magic of having a technology-based startup, especially in a field like robotics, and figuring out exactly what problem you want to solve and exactly how you want to solve it. Having done that, we are now, I'll skip over these videos, but one point I wanted to make about dexterity, which is sort of the point of our panel. If you play the video on the bottom, there's a couple of products that we have that are being deployed in footwear. So you can buy shoes at a Nike store that are created by Grabit appliances today. Chances are the scale hasn't reached where you find every shoe that are being made by our part, but a large number of shoes. On the logistics side, we have a product that is helping truck loaders load boxes onto trucks more productively. But I just wanted to sort of end with the thought that dexterity is not just what we perceive it to be, which is to handle complex objects and then manipulate them in our hands. Everybody sort of understands that from our English definition of dexterity. Dexterity can be things like moving a product on a conveyor belt in a faster or more efficient manner, or picking up one ply without disturbing a stack of cut fabric, if you play the video on the bottom again, which is sort of a big worldwide apparel problem where they cut fabrics in these stacks, and you can't automate it unless you automate that delicate task of handling layer by layer these fabrics. So I just want to leave you with the thought that the dexterity itself can be applied more broadly than anthropomorphic or even grasping tasks. There are several tasks that are maybe in some ways simpler that I would encourage you to think about, that are also tasks that are big opportunities for automation and big opportunities for business that do involve dexterity, but just in a different way. Okay, I'll end here. Thank you very much.
Okay, so I guess before we start, we heard from Harsha. Maybe the other panelists can shortly introduce themselves and what they do.
I'm Paul Ekas. I'm founder of SAKE or Saki Robotics, and we make a gripper. We're located in Redwood City. We sell these around the world right now. And the objective that I had in taking the company towards grippers was fun. And I've seen all the cool movies over time. And I wanted to have a gripper in the market that was incredibly inexpensive and durable, so that someday robots can be doing useful work in service-oriented industries, and we'd all enjoy it. Right now, the bigger markets for this is warehouse packing. But the objective is to be having robots clean the room and the dishes and everything else using grippers based on this technology. That's SAKE Robotics. Thank you.
Okay, so my name is Juan Aparicio. I work for Siemens. I'm supposed to be the disruptor, the disrupted company. So I'm heading a lab in Berkeley, and we work very closely with universities, mainly Berkeley and Stanford, in the areas of automation, autonomy, and robotics, of course, bridging this gap between the university work and the business side of things. I have to thank also the organization to put a focal point of light in front of me. So that will help me not getting asleep, because I haven't get so much sleep as I have a baby last week. Oh. So I was, thank you. So I was in doubt until last minute, but I'm very happy to be here.
Is the robot changing the diapers?
Not yet, but we will talk about that. So thank you also the organization for inviting me.
Hi, my name is Matt Howard. I'm with Norwest Venture Partners. We're a firm that's been established for about 57 years, about $7.5 billion under management. And I lead the B2B efforts at Norwest. And we focus on everything from consumer to enterprise to healthcare to IT services. I'm very active in the AI space and robotics. So thanks for having me here.
Okay, so I think we can get going with the first question that perhaps is more on the technical side. So where do you think that software only or AI only solutions are going to face a dead end, and then you will need some sort of hardware leap to overcome this obstacle? Or do you think you have that in mind already?
Do you want me to go first?
I guess I want to hear from all the technical people.
I used to be I used to resemble that remark. I think that there's tremendous strides that's been made, as you showed in your slides, with using very simple graspers along with AI. But as Paul can describe, graspers that look simple are not necessarily simple. There's compliance, there's stiffness, there's various factors that need to be designed in the hardware to optimize the overall task. So in certain areas, namely picking out of a relatively structured industrial environment, that's probably where we've made the most progress. This problem called bin picking, where you sort of have a box of stuff and there's no other clutter except inside that box, and you can focus in on that and grasp one item out of that. And there's tremendous strides made there primarily on the software side, but using some what I call mechanical intelligence on the hardware side. There are other problems that are completely intractable unless you also innovate on the hardware side. I showed an example of that, just picking from a stack, this one layer, right? How do you solve that with just AI and software? If you grasp it, you'll disturb the stack, and then you need even more AI to figure out where the wrinkles are and where the edges are and so forth. So there are clever, simple hardware breakthroughs that enable certain tasks to be performed that also then leverage the software. You have to have the right hardware platform, I guess, that focuses on the task.
When I started going down the path of developing this, I met with a guy who makes prosthetics and teaches at Stanford. Comes in, does engineering, helps with engineering students. And he was very interesting. He said, I can't remember the statistic, it was very small, some 80% or 70% or something like that of prosthetic hands are rejected by the owners because there's no feedback, right? They can't feel it. And he said the day before he had a young girl real young girl who had no hands, and she was in and she reached into her purse and went down and got lipstick and put it on because she had feedback. And dexterity needs feedback. So we have vision, we can see stuff, we can come around, we can pick this up, and we know that's there, but we can't really feel it very well. And so there's some areas, I think, in dexterity that will start to open it up far beyond bin picking is when we can start to feel stuff here. So I'm working with several different manufacturers of sensors, and the challenge with sensors is durability and cost and putting them out here. But as soon as you can sense shear, or you can start really feeling what's going on, then the machine learning has something new to work with. And I'll say just the simplest thing is, if a robot's in a restaurant picking up glasses off of a table, it will help to have shear to know if it's succeeding. And I'll just put the simplest thing on there. When you pick up an object like this, you don't squeeze it as hard as you can. You just squeeze it enough so it doesn't slip. So shear detection is an example of hardware coming into the gripper space that will change what we're able to do with machine learning behind it. And then I'll just throw one other thing out here. This is simple, right? This doesn't look like your hand. A couple of things happen when you go up to something with the complexity of your hand is you have the machine learning problem explodes on you, may be tractable now. And then you also have all these motors and wear points and all kinds of other things that can cause problems. So there is when you look at robots in general, they're going to have simple stuff like this, or they're for show, like for a pepper robot. So just some thoughts.
Okay, so I agree with you, Paul, on the fact, like, if you just try to put a key on a keyhole with just your vision, it will be impossible, right? You need feedback. Haptics are very important here. Now, in the controversy of hardware versus software. It was interesting. What I hear, it was not very far away from here. It was in the first conference on robotic learning where I hear this. It was from Rodney Brooks, which I don't know if you know him. He's the founder of iRobot and Resin Robotics. And he had a keynote over there in the Google headquarters. And he started with a slide saying, AI is overhyped, machine learning is overhyped, robots are overhyped. This is a guy that sells robots, and he's telling you this. Probably the biggest market was in the room. Everybody wanted to buy one of these Sawyers, one of these Baxters. But I think it's true, right? If you buy today even a Sawyer, that is one of the new robots from Resin Robotics, the gripper that they use is the same technology that 40 years ago. He recognized that, he invented that in Stanford 40 years ago. So I think the key here is a mix. There are like, it will be software for sure, but there is still a lot to be done on hardware. On automation, it's always something that you sense, then you control, and then you actuate. Luckily, on the sensor side of things, vision has come a long way. And that's because we have our mobile phones in our pockets. Like cameras are everywhere, and the technology has been developed dramatically. But we haven't seen that on the hardware side, and that needs to happen.
Yeah, I think there's a few things. One is around sensor fusion. I think today you're seeing a lot of sensors coming together. How do you process the information? There's some more development there. Also seeing some interesting development around 3D radar, which I think is going to be very important for robotics going forward. And I think, quite frankly, we just need mileage. I think getting these robots out there and capturing a lot of the learnings, so for scale-out properties. So I think it's all doable. I think we just need mileage from here.
Okay, so I think for the next question, maybe we start from the other side, because perhaps we can start with more of a business spin. So what is, in your opinion, the biggest untapped opportunity that could benefit from dexterity? What is the biggest untapped market or sector where this could really come in and disrupt?
Yeah, I think there's a couple of things. I mean, if you look at, I'm largely focused, like a lot of us, on e-commerce. I mean, as a society, we've moved from getting deliveries in 7 days to 3 days to 2 days. Now people work on 1 day and the whole return. So I think the logistics can unlock a lot of efficiency. I mean, the average picker today walks between 6 and 7 miles a day, and it's hard to retain people. So I think, especially with the panelists here, I think this is going to unlock a lot of potential, but I'm really focused on the logistics and in the e-commerce space. I mean, it's a low margin type of environment, so precision is very important.
Mm-hmm. Okay, in order to add to that, maybe agriculture too, right? It's a very complicated space that requires a lot of labor, and it's hard, right? You don't want to bend yourself to pick up a strawberry. So that's an area where robotics has a big potential, and dexterity is needed, because you want to also potentially also grab only something that is ripe, right? And then going back, you need these haptics, right? But what we need to also understand is the other side of the coin, that it's not, automation doesn't make sense everywhere, right? And Tesla is feeling that, for example, right? Today, right? And I think it's known, it has been published, and Elon Musk has recognized that it was a mistake to try to automate the final steps of car assembly, because that requires a lot of dexterity at the end of the day, right? I don't know, it's not well known, but the amount of robots in automotive has increased, but also the amount of people working on there, particularly on the final steps. So we have to differentiate the tasks that still make sense to do with a human, because they require a lot of dexterity, and the low-hanging fruits, like in this case, literally the low-hanging fruits of agriculture, that we can automate with a little bit more of dexterous manipulation.
Yes and yes. I look forward to, I have the dream side of it, right? When can a robot come in and do some useful work? So I see some cool stuff going on there. It's the ability to teach a robot to do something that is historically been hard to do. So Waseda University is an example, Berkeley is an example, where they're actually humans driving for a bit and teaches the robot to fold the shirt, and then the robot can fold the shirt, right? And that's a really soft skill And they're able to do it through a teaching mechanism so that they teach it, and then they can throw different shirts at it, and it can still fold that. And that's now 2 years ago at the 2015 Amazon Picking Challenge, none of the teams could recognize all the objects, right? So what I just said is a real hard thing that they're actually able to do now at a research level. And I don't know how fast this stuff's coming online, but it's unbelievable how fast it's changing. And so I think that we're going to be able to see robots come into the apparel industry and do, more management of soft goods and do some stuff like that as well. That is obviously behind where we are in warehouse, but another enormous market that's in the supply chain and has just more need of dexterity for handling the objects. So, lots of opportunity.
So since most of the obvious ones have been taken,
You're in a hard spot.
so couple of just sort of thoughts. One is obviously the low-hanging fruit is in a more controlled environment like industrial or even agriculture. I would say is more controlled than the clutter that my kids leave in the house, right? So sort of home robotics and dealing with that clutter is probably sort of the next level of manipulation that is a hard problem and can get unlocked with a combination of software and hardware, including navigation over rough terrain. The other area that we often get a lot of people asking is in sort of mesoscale handling of things that are about a millimeter cube in size scale. There don't appear to be anybody sort of working at these size scales.
What will be the application?
The applications are in certain areas of semiconductors, where there aren't pick and place machines already making things, in small levels of manipulation of pills and other things that don't need to be handled by humans. Back to dexterity, this is one of the hardware limited areas in that millimeter scale. There just isn't much that can be done with conventional graspers that require that delicate handling at that scale.
Just one comment. As someone active in robotics for agriculture is a very messy domain.
Yes, of course.
I can tell.
And the quality of life of a person over 65, 70 years old will dramatically change if they can simply get out of bed. Like a lot of people need to go to a special place just because they cannot get out of bed. And that's a task that a robot could do, right? So also handling people will be a huge thing, particularly with the aging of the population. Right? And that's a different grasp that what we have seen here, right? That's particularly different.
Yep.
And I'll just extend that to handling big things in general. Yeah. Sort of, we go to a lot of warehouses and to implement some of our products. And one of the things I see is very not so well-built people trying to handle a 60-inch TV or a futon in a box or a tree. People ship trees, I couldn't believe it. Yeah. Or coffins, I've seen tires, I've seen all kinds of things. And these are being handled in a back-breaking fashion. So at a different size scale, this is the sort of individual item picking problem. Mm-hmm. But even an assist device that can handle that size scale is very interesting.
Okay, so given that there are so many opportunities, one just has to pick, literally, no pun intended. So for someone entering in this domain, or for someone remaining in this domain, what is the right business model? I mean, this is something we talked earlier on. You can imagine a number of different options, software as a service, hardware as a service, you rent, you lease. What do you think is the right business model? Or what are the possible right business models?
Shall I start?
Anyone. I think we have a lot of wisdom.
So we've tried a few, and sort of, the combination that we have ended up with is a a sort of a hardware sale combined with a consumable, combined with a software, and in some cases service piece of it. You definitely want to, this is not rocket science, increase your recurring revenue as much as possible relative to one-time revenue, especially because of the fact that the faster and faster your machine does the job, the fewer and fewer machines are needed by the customer. So sort of this is the fundamental contradiction of selling automation, right? Applied Materials knows this well. So you definitely want to try to take advantage of a service or a recurring component because, while this space, the B2B industrial space is conservative and takes time to develop, it's also very sticky. Once you're embedded, you're sort of really in there for hopefully a long period of time.
I think the key is, you have to have a certain amount of flexibility because, especially in robotics, some companies care more about OpEx, some care about CapEx. So what we're finding is, especially for a startup where you don't have the power to dictate to a customer, I think you have to offer multiple business models. You have to offer subscription and CapEx. And especially in robotics where it's seasonal, where you can have a rental fleet. So you might have a steady state infrastructure subscription or CapEx and then have a rental for certain seasonalities. Because depending upon the seasons and the situation, the financial health of the customer, they might have different pockets. So I think today, you really, especially for the early adopters, you have to be highly flexible. You got to get the robots deployed and show customer success and take it from there.
Mm-hmm. So I was very amazed last year when I went to an automation fair in China to see like at least hundreds of companies that do like the same robot all over again, right? And really good replicas of the Kukas, the Fanucs of the world. Mm-hmm. So hardware is becoming, and robotics hardware is becoming a commodity, and it has to be, right? It has to come, the price has to go down in order to be widely adopted. And in order to compete, you need either to be very innovative and have the IP, or have new business models here, right? In that regard, for example, for Siemens, right? We were once a startup, right? It was 1847. 170 years ago, right? So, but we recognize that we don't have all the innovation inside, but what we have created, for example, I think a few years ago, and we're ready with B3, is something called MindSphere. It's our cloud platform, IoT, what we call our IoT operating system. And what it does is enables any company in the industrial domain to connect your assets. In this case, can be a gripper, and then enable new business models like gripper as a service, right? You could charge per picking, every picking that you do. Of course, that's very difficult for a startup to do the entire ecosystem, the entire platform yourself. But if you build on top of some huge kind of big corporate like Siemens, you immediately reach to thousands of customers, of potential customers. So that's, I think, how I see this dance between the startups and the more established companies, where we need to offer, to give the possibility to the startups to innovate and offer new business models.
This thing that you just mentioned about the MindSphere and the startup hooking in, is that something you envision or something that is happening?
It's something that is happening. So it's an ecosystem that is growing. There are, I think, not so sure, but right now it's the Hanover Fair. So if you go, here in the US, if you go to our Berkeley office, we are around 20 people. You go to Germany and you see how big Siemens is. It's huge. So we have an entire, almost city over there. But there are many companies that are building apps on top. And when we say automation apps, it's more difficult than just an app on your phone. But for example, KUKA is on board, Festo is on board, these kind of companies, also other startups that can build applications, automation applications on top of this MindSphere app platform, and immediately unlock services like prognostics, fleet management, whatever you can imagine as a service. This is happening already. So if you are interested, let me.
So you don't want to be disrupted, apparently. Paul, yeah.
I don't have the right business model by intent. So if you're trying to get funded, you have to do something bigger than what I'm doing. It's interesting what's happening in the robotics space because there are gripper manufacturers and there's torques on them that make them become something else. And so example, that's right-hand robotics. An inverse example, that's Kindred out here, where the warehouse chain is getting integrated from a software point of view, and they're taking ownership of the gripper because they recognize its importance in the supply chain. That is not the model that I have. We're self-funded and intend to stay that way, so I can't afford to pull on a world-class AI team, which is not easy to get to these days. But the flip side is, so how do I make my business go? And so I'm playing with ideas around there. It is a generic technology. It means it's very wide, not focused, which is kind of all the wrong rules. But one thing that's pretty slick on this, making one of these is not easy. We have patented technology on here. And so coming from 30 years as semiconductor, one of the things that we're very interested in is licensing this, because there are more companies that want to make robots around the world, and having a decent gripper is a hard thing. So that's an idea that we have. And as you said, we'll be flexible, right? The right guy comes through the door or gal, and yes, we'll jump. So,
I mean, we're in the early adopter phase right now. I mean, we're in the first inning. And I think one of the challenges I've seen sitting on boards is how do you blend the tactical needs, and that is the tactical requirements that gets you a purchase order, with a strategic investment for a company for the long range. So you have to kind of balance that of what are you trying to do today and as opposed to tomorrow. And I think it's a challenge for a lot of robotics companies. How do you balance the tactics and the strategy?
So just a few thoughts from me. One is that our business model over time evolved, and even over product stage evolved. So there's a time when it's sort of problem solving, where you want to solve the whole problem and own the solution. There's a different time when your demands are operational, service and support in multiple countries, manufacturing scale up, discipline of sort of supply chain, lead time, all those kinds of things, which you're not necessarily the expert in. And the key is to recognize that at that point and partner with people who might be. So that's sort of from a partnership standpoint. From a business model standpoint, or revenue model standpoint, I was surprised that many people in the apparel industry, people are actually paid by the piece. So you're already, there's an incumbent culture that rewards productivity in some ways. Of course, that's a double-edged sword with people, because you can drive them, really, really hard and create sweatshops. But some interesting ways to approach robotics might be sort of to leverage those kinds of things. It's more challenging than it sounds. One of the other challenges is if you're going in with a leasing or pay by the piece or sort of this rental model, which is very good for the customer, as a startup, it increases your upfront funding needs. You have to fund that capital and take on that uncertainty of the rental. So while on the 6-10-year horizon, it looks super lucrative, in the 1-year, 2-year horizon, you're all of a sudden raising more capital, and it's tough to raise that capital before you've demonstrated large scale already and get cheap that type of capital.
Better be sticky, or you're going to be in big trouble.
Right, exactly.
At the end of the day, also something that automation traditionally hasn't capitalized is data, right? Because, I mean, even Siemens selling tons of PLCs, we usually don't know how people use them, right? You sell the equipment and goodbye. And you sell a lot of equipment, but goodbye. And the same with grippers, right? You sell them and you say, okay, it's a very successful gripper, but I don't know how my customers are using it. But if you can also hook up into their revenue and say, okay, we get money by understanding also your business model, by when you make money, I make money. That way I also own the data, I can improve my designs, and the next generation will be better, and then you are hooked up into that cycle. So owning that data and making money out of that is also very important in the automation domain, that hasn't been able to do that so far.
Okay, I think we have time for maybe another quick question before we switch to the questions from the audience. So this community is made of entrepreneurs, investors, researchers, engineers. Where do you see this community in 5 years from now? I guess you see all yourself being rich and successful, but besides that, from the things of what can be done, 5 years from now?
Matt, you want to start?
Wow, 5 years from now. I think we're now in the early adopter market. Clearly, folks on this panel are pioneering, and I think once we get the products out there and we get to scale it, I think we're going to start seeing the next phase is scaling. I think we've got the early adopters out there, and I could picture virtually every category. We've seen the power of surgical instruments, of robotic surgery. We're starting to see agriculture, industrial, gripping, warehousing. I think the early adopters are going to pioneer for a lot of other markets. So it's clear that we're just in the first piece. I think part of the big pioneering that needs to take place, we'll see over the next 5 years, is around perfecting the AI engine. Now you see a lot of profiling. You're starting to see the early use cases between TensorFlow and Caffe, and we're trying to do a better job profiling which architecture is better for which type of application in AI. One of the things that's really interesting is I still see a lot of further development around computer vision. Even a robotic arm, the camera placement, you can picture if a camera is over the shoulder, blocking the object. So there's still a lot of finer points. I think polishing the stone is really required here. And so I think we'll see much further deployments.
Mm-hmm. I completely agree on the AI part. Working with universities very, very close by, I can see what the next wave of innovation is coming. And it's funny because when I started here and talking with some roboticists inside the universities, it was all about pure robot learning. I don't need models of the world. I will learn it. I will have enough data. That's the famous kind of Google farm of robots that took 6 months to learn a grasp. But the industrial domain is different, right? So we don't need to throw years and years of good old-fashioned control and replace it with AI. It's the combination of both. And if you ask me, I think the word autonomy, for example, has been misused so far. I think the future in 5 years will be more autonomous robotics that will add the flexibility needed. But this autonomy will not be born from the AI, it will be born from the traditional automation, like just an evolution with data and AI on top. So whoever cracks down this combination of traditional control for most of the tasks, but when you are really close to the part, when the physics start to be complicated to be modeled, that's where AI needs to shine. And still people haven't cracked that down. So we need, in the future, whoever does that, it will be a big success.
Any other thought?
2015 at the Amazon Picking Challenge, nobody could recognize an object. We're only 3 years beyond that, and it's dramatically different. So 5 years out, it's a long way. It's changing super fast. So.
Yeah, I echo those thoughts. One area that I think is a little bit sort of under-researched or underappreciated is sort of the human part of the learning, meaning mixed models that involve artificial intelligence, but also human intelligence. And for example, teleop, mixed autonomy with teleop in the loop for at least the learning early stages, I think is a very, very promising area for many of these things, like where you start to get to polish the stone. That's when the AI models are powerful, but I think you can supercharge them with adding some human intelligence, learning from how humans do tasks. In robots, one of the more powerful recent phenomenon is collaborative robots, right? Where that's not exactly what I mean, but it's when you add the human beings and the robotics and the intelligence together.
I think is the term
yes,
used.
And maybe the human exercising and perfecting and teaching the robot. I think that's that's one of the things that could supercharge this.
Yeah, and we're starting to see collaborative robots. I'm involved with a company called 6 Rivers. It's the ex-Kiva team, part of Amazon Robotics. And we're just starting to see collaborative robots being deployed now in scale. And you could see the coupling with grippers and collaborative robots. You're going to see a lot of fusion of technologies come together. Now a lot of these things are discrete, but in the next 5 years, you're going to see a lot of collaboration.
Also, also, I like to say that I'm right now hiring roboticists, and to me, a roboticist is like a Renaissance engineer.
Yes.
So they need to know control, they need to know perception, they need to now know machine learning. It's a very complicated mix of skills, and there are very few, because automation is still, and robotics as part of automation is more an art than a science. If you go to a factory, these system integrators, they are artists. They can automate everything, and it's based on the domain knowledge. So it's like kind of in the 90s when you bought a computer, you need to install this driver for this mouse. It's still very difficult to put a robotic system together, because a robotic system is not just the arm or the gripper. It's the arm, the gripper, the fixture for the part, the cameras. There are a lot of parts, right? And this, putting that seamlessly, like a very easy integration. We are not there yet, but in 5 years, I hope we are.
Okay, so I think it's time to switch to the questions from the audience. There is a large number of questions, so I apologize if not all of them will be asked. And I'll pick the first one because it seems like a lot of people are asking about what are the opportunities for robotic manipulation in healthcare, medicine, and also what are your thoughts about waste management and recycling? So whoever wants to take this.
Okay, start with the healthcare part. So, okay, as I said at the beginning, I was some days in the hospital last week with a new baby. And when I told the nurses what I was doing, okay, you work in robotics, I'm gonna lose my job. And it's like, no, nurses will never lose the job. This is something that is impossible, right? You need the human care of things. On the other side, the operation side of things, that is happening, right? You need more precision, and that's what a robotic solution can offer you. So there will be tons of solutions around that. On the operation side of things, when you need precision, right? Then on the recycling part of things, for sure, right? And even in your home, right? This, if you see the Roomba cleaning thing, this is still a very rudimentary device. Whoever solves that problem in a better way, like for example, if there is a toy in the floor that you can pull it away, that will be a huge advantage.
Yeah, we're seeing garbage tech. You know, we're already starting to see companies focus on that and managing dumpsters, and like a picture of construction where you have dumpsters all over. You know, virtually every company has a dumpster behind the building. How do you know when to empty it? When do you know it's full? How do you transport it? So we're starting to see a lot of those things today.
So just one caution on that front. You know, we shouldn't think of everything as a robotics problem. In a warehouse, boxes are not sorted by one, having robots route them or letters to the right destination. There are these things called automated sorters. It's an automated system, but not necessarily robotic, which is much faster and more efficient at figuring out the right parcel to go where and dispatching it. I think something similar will happen in waste management as well, where it's, you know, it's going to be a different paradigm of not necessarily reproducing what the human beings do, which is pick one by one and separate it, but more, you know, some technologies from robotics are going to play, like high-speed vision and those kinds of things, but probably something just to handle that sheer magnitude and scale will look more like a parcel sorter than a individual pick-and-place robot is what I think.
So I'll jump down the list because there is a question that I like, because I got interested in robotics 20 years ago because I wrote a simulator for robotics. And so one of the questions is, can anyone address how simulation can help hardware to design robots? And what is the role of simulation in this thing? We talk about the generation of data and so on. So, well, whoever wants to take this, you know, or is it's a hardware business, you know, where do you see the role of simulation in this?
So you had an interesting comment before on the, I think it was, go ahead, sorry.
I was gonna say that it's gonna be huge on different angles. Like for example, last week we ran a big hackathon event at UC Berkeley, and the team that won was precisely doing that, doing a mix of autonomous cars with simulation on the side. For example, for autonomous cars are robots at the end of the day. Being able to, without driving a single mile, test that your algorithms work in simulation, that's very important. And for doing that, you need to do this, also simulate the sensors and all these kind of things. Siemens has just acquired a company called TAS International that does precisely that. And from the point of view of AI and machine learning, I mean, you know that the price that you are paying is the huge amount of data that you need to collect, right? So if you can simulate that, that's even, there is tremendous value on doing that. Virtual commissioning, if you go to a factory, that's tremendous too, right? So from the point of view of a big company like what I represent, this is a big part of our portfolio, the simulation part, but also the real world part, and coming together. Yeah.
The simulation in grasping is huge. They've got very specific simulators just for grasping. Then they've got full physics engines that they're using for robotics, like Gazebo here. So if the simulator space for robotics is rich, and it's a lot focused around two fundamental things, not hitting things. So being able to do this around here means you know what's going on in your environment, and you can simulate all that and verify that. The second one is, if I'm going to come up and grasp something, I have to be able to simulate approaching it, the grasp, the quality of the grasp. But if I can do all of that in simulation, which you can, and they get better at, and there's issues, but simulation, then you don't have to do it in real life, and you can multiply up the permutations of it. And Autolab's system for doing the grasp planning, DexNet, just does that, actually synthesizes all kinds of objects, and then it learns how to grasp them, and it trains a neural network on that. So when you come up to this, it can look at these and say, that's about a bottle, and it can pick that up, and it's about like something else I've seen, it can pick that up. And that's available today, and that's all built on simulation, and I think that that's critical for the success of it, because you couldn't synthesize all the stuff in real life and learn how to do that.
Mm-hmm. Particularly for any, I mean, I said autonomous cars, industrial, even at your home, you don't want to put a solution out there that it hasn't been validated, but in order to accomplish, for example, the number of miles that a normal car will need to drive out there, it will be millions of miles, right? So can you bridge that gap with simulation? And you can, right? From the point of view of grasping, one thing that is still very difficult is when it's contact-rich dynamics. So the contact-rich, when I have to simulate how I push this, if I simulate that, if I do that 10 times, it will be different. Just a grain of salt in this surface will make this gripper go one way or another. So also the mix of simulation with real-world data and how these two things mix, that was what I was referring before of control versus AI, how these two things mix together. This is still an open question.
So here's a question for Harsha, but probably the others can chip in as well. So you mentioned community, and the aligning with the experts is crucial in the early stage, or sometimes you have to realize you cannot do anything, and it's essential to partner up. So are there ecosystems of partners that can benefit this community, or is something that goes on a case-by-case basis?
It's at least so far it's very domain specific. There are certain ecosystems like what Juan was talking about around robotics in general, but it typically tends to be more domain expertise, and the kinds of partners you want to take on are typically experts in some particular domain that you're focusing on. One thing I will say that in the earlier stages when we were doing product development and working with it, it was important not to partner at that point, because we were sort of disrupting the way something was constructed, and the channel was sort of not really collaborative to that. But once you show the value with the end customer in the loop, now all of a sudden you do have partnership opportunities, at terms that are much better for you as opposed to selling through the channel from the get-go.
I don't know if you want to add, otherwise we have plenty of questions.
I guess it's, for example, for industrial applications, it's very difficult for a startup just to show credibility and go there, go to the automotive companies of the world like BMW and said, look, my gripper is better, you're going to do more cars here, you're going to perform better. Without a giant in the back, and these automation companies tend to be big because there is a lot of capital investment there, it's difficult to succeed. So this kind of partnership between incumbents and people and companies that have been around for a while is important. Of course, when it's a win-win for both of them, right? If you are going to disrupt the big company, then you better not partner.
So I guess it's an unavoidable question that seems to have been asked many times. So will robotics bring jobs back to the US?
Yes.
I mean, this is a biased or panel for sure. We are all roboticists one way or the other, but
Well, we're finding in the area of collaborative robots, I mean, there's some jobs that are just hard. There's some jobs out there that just have negative churn. We just can't find enough people, whether it's farming or warehousing. So I think we're starting to see an embrace. I noticed from my involvement with Six Rivers, a welcoming, a relief in certain cases. So in that case, it's just trying to maintain a workforce. We're seeing in manufacturing, in hardcore manufacturing, the embracing of machine and robot and people. So depending upon where the element is, so far we're starting to see it's net adds. I think you brought it up early on, is that it takes more people, there's technician support. Down the road there'll probably be some retraining requirements, but so far it's I'm not seeing any signs of replacement so far with my involvement in robotics.
So I'm part of the technical advisory committee of Manufacturing USA Institute that has, I don't know if you guys know, but in the previous administration, after the economical crisis in 2008, decided to ramp up manufacturing in the US, and they set up different institutes. One of the latest ones is called ARM, Advanced Robotics in Manufacturing. And what we are doing is precisely this, is ramping up, increasing the manufacturing tissue in the US and bringing manufacturing back to the US. And we are a lot of companies involved on this and making this happen. And a big part of this institute is the education and workforce development. I think a big thing is that we will need better tools to retrain people. That's true. Like maybe doing the same job for 60 years will not happen, or 40 years will not happen anymore. But we will need faster tools to retrain people, but people are still needed. I still remember in the kickoff of the institute, there was a VP from Airbus that was saying, are you guys crazy? How can I get rid of the people? I have a backlog of 7 years. If I order a plane today, you will get it in 7 years. And it's because I don't have enough people to build these things. I want automation. I want robots to work along my guys and build faster.
So
I have opinions, but you guys all read the news. I see, right? I think service sector jobs are at risk. I think manufacturing jobs are helped, right? If I can do manufacturing in the United States instead of overseas, that's going to bring jobs to the United States. I think their service sector jobs are at risk, right? Driving trucks long distance, so I don't know.
Mm-hmm. I think it's going to be a while before we start seeing, cars driving around every place with no steering wheel and everybody being in the back. I think this is where I said early on about the need for fusion. I mean, there are amazing challenges we have to deal with. You could picture a car, a robotic element, where a car has to make a split decision choice. Do I rear end the car, or do I run over an animal on the side of the street? I think there's so many corner cases in weather that we're going to see a long time before we see a big displacement. But I am optimistic we're going to see much more manufacturing come back to the U.S.
So just one comment on that. the trend that we're seeing is not necessarily geographic, like US versus China. It's really urban along, these, it sort of goes into this mega cities type of trend where you're sort of, the consumer is pulling everything closer to him or her. Manufacturing, warehouse logistics, everything is sort of being pulled like a magnet by consumers. And so I think that bodes has different trends for people who are living in these cities and working in these cities versus more rural areas, which is sort of where traditionally factories and warehouses used to be located all over the world. Doesn't matter in the US.
And to your point, we're seeing way much more vertical integration. You see what Amazon is doing, and Google and Tesla and Apple, way more vertical integration, which is going to require tremendous logistics and a huge opportunity.
I just want to put one out there. One of the coolest robots to look is manufactures T-shirts, and they built it in the southeast, and it's a Chinese-owned company. And I think the T-shirts go on these rollers, and they can precision control where it goes to the stitching machines by looking at the stitches on the fabric. And so they can make a T-shirt for about 40 cents, and it's built in the United States, and the throughput's tremendous. It's a Chinese company that owns it. I think it was a US company that built the automation system. It is based in the United States, and it's going to pump out T-shirts.
And the technology came out of Georgia Tech.
Did it? Yeah, so that makes sense. Locally around there. So there's one where you've commoditized people out of stitching shirts, but you brought it over here.
So we had a similar discussion in a panel some time ago, and one of the panelists said that there has been traditionally some sort of hostility against immigrants through ages. And robots are immigrants from the future. So this is why people look at them with skepticism. And I think there is some truth in that. A lot of people apparently ask about Google. There is no one from Google here, but it's well known that Google has acquired a lot of robotics companies in the past. So the question is there anything that you see coming out of that conglomerate that is in this space, or are they doing something else? What do you know about that?
I think the most interesting one is Google sold off the key assets to SoftBank. So they're under a different owner now. Some of the, like Boston Dynamics and a couple other things got included in that. So some of their coolest stuff that you saw was spun out.
No longer
which is SoftBank, which actually has a beautiful vision for how this stuff all goes. So I'm actually pretty excited for that.
Okay, there were two paths, and that relates to what I was saying before, traditional control, which is Boston Dynamics. If you see and read the technology behind, they don't use any AI. It's carefully crafted control, and they are able to do amazing things, versus what Google tries to do that is pure data-driven, just data, data, data. I think the future will lie in the intersection of both. So unless they make a shift, I don't see that very promising.
Okay, there is another question that is probably interesting for the bigger companies or for the bigger players. Are there standardization efforts in the hardware platform and software API of robotic systems, and do you value those? Some people like standards, some people don't, for good reasons.
I think people confuse sometimes standards and open source. I think standards create a lot of, let's put it that way, a lot of business at the end of the day, a lot of value. I think standards are needed, and as I said before, they will be a solution for this world that we live in, the robotic world today, that is more an art than a science, because there is a lack of standards. On the other hand, open source is nice, but it's kind of the spice that you put on top of the standardization of efforts. So I hope we all work on standards in this domain. There is something called ROS that most of the people in this community know, but it hasn't been widely adopted, and it has some still white spaces that need to be filled, but it's promising.
There's some interesting de facto industry standards like CUDA, part of NVIDIA. that's unlocking a tremendous amount of work, abstracting some of the lower level stuff for a lot of robotics companies. So some de facto standards.
I mean, I agree with Juan. Our machine, this machine we call Stackit, has 5 different pieces of software because there's motor control that's different from ROS, which we also have in there, and there is no integrated system at this point that allows more developers to hire. Now you're hiring 4 or 5 different people with domain knowledge in specific areas. I don't know if driving it from the top down is necessarily the way to go, but just integrating more either de facto or somehow sort of more integrated solutions, I think makes
I think
a
the
lot
real
of
challenge
sense.
is the back end of this whole thing. I mean, the arm, the actuator, it's really the brains that are, and the sensoring and the softer things, which is all going to be the back end and the compute side, in my opinion.
Mm-hmm. So maybe a question for Paul and Harsha, and I understand that your answer may be biased because you have your own company, but what are the exciting hardware technologies coming out of the gripper world except your 2 companies?
Did really nothing.
You have everything there, right?
Sensors are interesting because they're hard. They're not integrated to all the rest of the systems. I'm talking physical sensors. So I like watching that. I think it's not a huge deal, but in terms of dexterity, I think it changes stuff. So I'm watching right there, and it applies to everybody. They can fit onto anybody and add sensing.
Harsha?
I don't know. I'm not a gripper junkie or robot junkie. A friend of mine has a company that's doing agricultural picking that uses a gigantic blower to as its end effector. That's the gripper, right? It's a massive vacuum cleaning hose almost, and that does the job really, really well. So why do you need to make advances in picking and create the human hand and do it exactly the way humans have been doing if there's a better way? So I mean, I just encourage everybody to not sort of think of these tools and then how, sort of the problem determines the right tool to use.
I think I'm familiar with that company. I mean, it's an amazing project, and just to spot a ripe apple, right. And where's the sun shining and reaching in. I mean, tremendous amount. The balance of system is very impressive.
Okay, I think that perhaps we can go with the last question because it's 8:21, and will the robotic revolution create new industries? Has it created new industries, or will it simply help automating existing industries? It's kind of these 5 years out that we talked about earlier on. What's your take?
I think we still don't know. That's the beauty of it, right? For example, when the press was invented, when the first printer in the medieval ages was invented, right? Like people, you will say, okay, you displace the people writing books by hand, an entire industry will disappear. But on the other hand, there were some very intelligent people in Italy, Murano, and said, okay, more people are now starting to read. They realize that they cannot see. I'm gonna treat these glasses, and the glasses were born. And there's an entire new industry that nobody was caring about before, right? So we still don't know, and that's the beauty of it. But I'm optimistic that more industry will be created.
I mean, I wonder if the car industry created more jobs than the horse and buggy. I mean, the displacement. I assume more jobs are created by the automobile industry than the horse and buggy.
So I mean, I think there's, as these things evolve, there's all kinds of different creative business models you can do, right? Why can't I have rent time where once a year I hire one of the best chefs to cook using a teleoperated robot in my kitchen, as an example. Cool. So I'm just sort of throwing wild ideas out there, but the point is that once you have these capabilities, just like the internet kind of indirectly created e-commerce, which disrupted logistics, a completely non-IT industry.
Well,
we just
Amazon
don't
cloud computing.
Yeah.
I mean, it was a derivative, right?
Right. So we just don't know the human creativity that gets applied once some difficult problems are solved that in all kinds of business models.
I think you've got a lot of cool things coming together. You got sensors that see everything. You have potential for autonomy, something that knows who you are, right? Robots see you all the time. Alexa can see you in your house now, and they can talk to you. And I don't know what's going to come out of that, but all kinds of stuff.
We don't.
Having things that you can interact with, that changes all kinds of things. Lots of opportunity.
All right, it's 8:23, and Stefano told me that at 8:23 I'm supposed to ask you if you have one final thought for the audience, each of you, very brief one. In whatever order you prefer.
I've already talked enough.
Well, I think just to take the first thoughts, but I think it was a very interesting discussion, and even now, the last question, in few seconds you came up with a new idea, right? A new business, and I think that's very interesting of what robotics industry is going to be in the future, right? We are at the beginning of a huge revolution, and the robots that we have in our minds, these androids, may not be what we think about robotics in the future. I think autonomy is the new automation, and we need to work towards that.
Well said.
And that perhaps is our last thought for
my thought is it's very exciting going forward. Just the last few years, and it's changed because of software and machine learning and all the system around it. It's not changed because of the hardware, but it's changing super fast, and it's doing amazing things. It's faster than I can believe. It's amazing.
Applause, please, for the panelists. Thank you for sharing.